Good afternoon, everyone. I wasn't sure what time it was. My name is Scott Davis. I work at Cast.ai. I'm going to talk to you a little bit about today about how do we combine observability with what Cast.ai is doing. So here's what we're going to go through today. Do I need that closer? Okay. So I'm going to talk to you a little bit about the observability challenge. What does that mean? What does that look like? What does Cast.ai, Prometheus, and Grafana do in that area? I'm going to talk about the integration architecture and what that looks like, and actually even engage in a little bit of a demonstration. It's going to be a live demo, so hopefully it all goes well, but I'm going to give it a shot. I'm also going to talk to you about visibility and optimization and an example use case of what I'm going to talk about today, and then go into the best practices and implementation around that. So let's start with the problem first. Complexity. If you've ever seen an architecture diagram of the current types of microservices, container orchestrated based architectures, they're very complicated. And you can have thousands and thousands of pods, thousands and thousands of containers out there. I've seen some companies in the enterprise space running up to hundreds of thousands of pods. And so it gets really complicated very quickly. And you combine that with the ephemeral complexity based off of what's happening in your infrastructure as things spin up and spin down to be able to control everything. It gets very complicated very quickly. Anyone have the opposite experience? Easy? No, yeah, me either. So what are some of the key challenges around that complexity? One is around cost management. If you have a very complex architecture with a lot of components, a lot of different services moving around, there's a lot of cost capabilities that are, or cost impacts around that. And so how do you manage all of those costs? What does it look like to try to understand what does my Kubernetes cost look like? What do my database costs look like? What does all of that come together and look like? And how much is that being charged? Performance monitoring, it's another key aspect area, right? So I, coming from an observability background, I'm obviously very interested in performance monitoring, making sure that systems are up and running. And so it's an important part about how do we monitor and continue to watch the performance of our systems and make sure that they're executing at the levels that we want to. And then finally, rapid response. As SREs, I'm sure you're all very familiar with, how do I get from MTTI to MTTR, right? I need to know right away that something's broken. I need to know what's happening, where it's happening at, and then how do I do to fix it, right? So there's a time between identification and actual resolution of that incident. So the timing there can be very critical. If you're an Amazon, an eBay, or e-commerce, that is literally tens of thousands or even hundreds of thousands of dollars per minute that you're losing. So that MTTI to MTTR is very critical. So you want to make sure that rapid response is as fast as you can. So how do we address those things? The first is through visibility. Now, a lot of my observability past has taught that there's three aspects. There's almost three pillars here, right? First, we got to gain visibility. That means how do I gain insight or actually instrument my applications, my infrastructure? How do I collect that data to be able to start to gain that visibility into what's actually happening in my infrastructure or my application or whatever that might be? The next is insight. I've got maybe in my entire application, I've got clusters all instrumented. All that telemetry data is flowing in, and it's going to be flying in very quickly. There's billions of active series per second coming in. That's a lot of data. How do I actually do something with that data? It's very important to be able to take that insight and say, all right, now I've got all this information coming in. What is actually happening within my system? That's fantastic, right? You can action off of that. You can get alerts off of that. You can set up your service level objectives off of that. That's all very fascinating, right? But the key part is action. What do you do with that data? What do you do with that information? What do you do with that insight and that wisdom that you've gained from collecting that telemetry? So let's talk a little bit about three of the platforms that we talked about. How many here use Prometheus? All right, got some hands. How many are using in production? Okay, about the same hands. Okay, fantastic. So Prometheus is very popular, right? It's a common platform developed really in 2012. There was a survey done, I think it was actually a Grafana survey that said 75% of organizations are actually using Prometheus in production. And it has a very active developer and user community. I think there's over 3,600 developers that the last time I checked the website. So it's a large active community that's going on. And if you look at it from a CNCF standpoint, It's actually the second largest project that's within the CNCF. Grafana. Who's familiar with Grafana? All right, pretty much everybody. Anyone using it for dashboards? All right. Using it outside of dashboards for observability? Okay, awesome. What are you using it for from outside of dashboards? What are you using it with? Alert management? Okay. What else? Anybody else using it for more than dashboards and alert management? Awesome. It's like a center of competency, center of practice for everything. That's fantastic. A lot of people know Grafana just as dashboards, right? It's very popular. 2014, Torkel came in and said, I'm going to change the world with the dashboards. And so everyone knows Grafana's dashboards, but there's so much more to it as well in the observability space, from logs and metrics and traces and continuous profiling. Anybody heard of us, Cast AI? All right, we got a couple of people. So we were established in 2019. Our founders had come from Oracle and they'd been working on several companies. And they discovered at that time that it was very difficult to actually measure cost and to optimize the cost around their Kubernetes environments. And that was the initiative. And that's what bore Cast AI. So Cast AI is really focused around intelligent Kubernetes automation. So what that means is, I guess, who here uses Kubernetes? Yeah. Okay, good. A good amount of people. Now, is it easy to manage Kubernetes? No. Yeah, no hands. Yeah. I've never seen anyone raise a hand to that question. It is a difficult thing to manage Kubernetes. So how can we make that easier and faster, but more efficiently in a cost optimization standpoint? So that's what Cast AI does, is we look to automate your Kubernetes environments, no matter where it's at, on-premise, in the cloud, self-hosted, however you want to do it. We looked at being able to optimize both from a cost perspective as well as a toil perspective. If you've ever been up at 2 a.m. trying to debug your YAML file with kubectl, it just drives you crazy, right? So what we try to do is make sure we automate all of that for you so that as you need to, we will automatically scale up and we will scale down for you, as well as being able to do that by procuring nodes, preferably spot instances, where you can get a major discount from that aspect, and then be able to apply those and put your workloads into those nodes. We shuffle all of that around for you automatically. We have about 13 or 14 different actual machine learning algorithms that are running constantly to make sure that we're looking at what are the spot prices that are going on in Amazon or Google or Azure and so on. We look around to understand what are the number of instances available, what are the different types of families, and be able to provision automatically for you to move workloads to those nodes at a cost-efficient manner. What we typically see is, if you look at this diagram, the blue line here on the typical early attempts to optimize, that is what you pay. So that's your provision. Most customers, development teams are going to over provision. Why? They don't want to crash, right? They want to have as much performance capabilities that they can out of their nodes. And what's actually the yellow line indicates is, what do you actually need? What are you actually using? And so that difference between what you pay and what you're actually using, that is lost revenue for you. That is lost money because you're losing money between those two areas. So what does Cast AI do for you? We automate that optimization and we bring those lines much, much more closely together. And we do it in a way that our machine learning algorithms look at a baseline, right? We can take into account seasonality. So if I always use the example of a bank or a credit union, there are certain times and certain days of the month that you're going to see huge spikes because people are, get paid on the 1st and the 15th, right? And they want to deposit their money. They want to get cash checks and things like that. So you often see spikes or seasonality in that. We can predict all of that and be able to ramp and scale up appropriately. We also do great at on-demand. So if you're running and also you see a huge spike or a huge increase in your bandwidth or your demand, we actually match that and are able to scale that very quickly. We have some very large customers. You can think of large banks, large institutions, large financial teams that trade stocks, and they all use us because we're able to help ramp that up very quickly. So on the last 2 slides I've showed you, so from the Prometheus aspect, Yeah, there's visibility. The little dot up there talks about how do we gain visibility inside of our systems. Grafana does great for visibility and insight. How do I get that visibility? And what do I do with that data? What does that telemetry tell me? For Cat AI, try to do all three, right? We want you to have observability inside of your Kubernetes environments. And we actually go beyond Kubernetes. We go database optimization. We do LLM optimization. We even do Kubernetes security around that. But we want to offer you that visibility, that insight, but more importantly, that action into things. So as a result of doing that, our value proposition is really around how much can we save you? And we're seeing around 20 to 80% as a normal, typical savings for our customers. That is huge. If you're spending $40,000 a month on Kubernetes, that brings it down to what, $7,000. It can save you an immense amount of money. So what does that integration look like? Because what happens is if you bring all of these three products together, these three solutions together, you're getting that total observability solution. So starting on the left-hand side there, you see the different environments. And so we also work on premise as well. But Cast AI integrates into your Kubernetes environment. We put a small agent in there that has really no impact on your execution. It brings all that Kubernetes data into our SaaS solution where we then execute all of our algorithms against that. What you can then do is use Prometheus to scrape our endpoint to be able to bring all the metrics and things that we provide into Prometheus. Now, you could also use Grafana Alloy. So that's another option if you're a big Grafana user, because then you're able to actually scale that up in production. Alloy allows you to have like clusters of Alloy agents running at any point, and you can easily scale that up. And then you can send that into Grafana itself. Now, the area where this is really meshing very well is you can have, like, for example, we do security monitoring of your Kubernetes environment. If you wanted to take a notification of an anomaly that occurs in that, you can automatically send that directly to Grafana on call or Grafana incident. So then you can go and use your escalation chains. You can automatically create an incident around that and be able to process and get to your MTTR much faster. And that's the whole idea. Just from a normal aspect of bringing that Prometheus scrapes in, all that data in, you can then do alerting off of that. And then you also can see all that in the dashboard. So I'm going to take you through the quick demo real quick to see what that looks like. Just real quick. So I have a Cast AI SaaS environment running. I'll show you that. I've got a Grafana SaaS instance as well. And I've actually got a local, basically a Prometheus container running in my Docker environment on my laptop right now that is scraping my Cast environment and sending that data, that telemetry data over to Grafana. So that's what I'm going to show you here. So here's that Prometheus data. That's all the stuff that I'm scraping from Grafana, from Cast AI. And here's an example of what Cast AI looks like. So what we're showing you immediately from your landing page is the amount of money that you're going to be able to save. So if you have multiple clusters, we can show you in an aggregate what that cost savings looks like for you. And we provide a bunch of additional metrics and data. So number of nodes, number of CPU, amount of memory, storage, and so on. And then I can easily dive down into those individual clusters. Now I'm on the available savings page. And what that means is I can see how much, by installing the agent within your Kubernetes environment, understand how much I can actually save you. So without Cast AI, it's $43,000 a month. With Cast AI, we can get that down to about $7,000 a month. And you can actually do some what-if scenarios around that. So maybe you don't like to use Spot. Maybe you're more of an on-demand company. Maybe you've got a lot of reserved instances. So you don't use Spot instances. If we turn that off, what does that mean? Cast AI can now get you still up to 73% of that savings. If you use Spot instances, we are very good at managing and provisioning and handling those Spot instances. A lot of organizations are scared off of Spot because of the whole idea. I've got 30 seconds to 2 minutes before my workload gets canceled, before like Amazon or Google recalls that, right? What we do is we monitor that automatically. We have insight from our machine learning algorithms into every cloud provider, and we watch the Spot instances. So we can actually predict when you're going to get interrupted. And we can also say, all right, if we know that you're going to get interrupted, we're going to move that workload off that Spot instance to another Spot instance at an equivalent or lower price. So that way you continue to save money. So you can go through here and play with all the different options to be able to see how much you can save. And then you can also look in more depth about what does it look like in terms of my environment. So here's a great example of where I've got a CPU utilization metric. And I can see that this green spot here is the average used. That's the number of average CPU usage that we're seeing. That's actually being used, right? That's what's being run. The blue area, the light blue area, is what is being requested. So your development teams, your DevOps teams are saying, we think our workloads and our applications need X amount of memory, X amount of CPU. And then what's actually provisioned. And so this is actually what you're paying because you're trying to make sure that you have a balance. That gap, that white gap in between that blue line and that light blue area, that is all the money that's lost. And so that's where we're actually bringing that down and being able to save you that 20 to 80% amount. So I've got this is kind of my demo cluster. I've got an example, one that I'm showing you here right now. So if I switch back over, so I'm in my Prometheus environment, I can see, I'm just looking at one of the Cast AI node metrics and you can see what's going on. Now I can actually move over into my Grafana dashboard. For those of you that have been working with Grafana, you've seen it before, that they have a new capability for drill down into the metrics, logs, and traces, and so on. I went into the metrics area, and now I can start to see all of the Cast AI metrics that we are providing from that scrape. And so you can see there's a ton of different metrics you can actually use to then be able to set up your alerts or be able to set up your SLOs or whatever you need to do to be able to trigger those alerts. We also provide you an out-of-the-box dashboard, so you can easily create a new dashboard, copy the JSON into there, and now you've got an automatic dashboard for everything from cost through specific instances about your CPU by lifecycle, memory, and so on. So we give you all of that basically out of the box, so you can easily get up and running. This whole thing took me about 30 minutes to set up, and 25 minutes of that was getting my Grafana Assassins up and running, but it was so easy to actually just get all of that up and going very quickly. So I have about 6 minutes left. I want to jump back in here real quick to the presentation. So taking action is the key part of that visibility, insight, and action pillars of observability. If you're not taking action, you're not really doing anything. You're watching things happen, but not doing anything about it. So the action is the key part about it. And most observability vendors are very good at visibility, so instrumentation of your application, of your environment, and they're good at insight, drawing out what does that data mean. A lot of visibility, observability vendors are not good at the action part. So Grafana does a great job of notifying you, maybe taking action on the incident and so on. Cast AI actually wants to do that work for you because nobody wants to manage 100,000 containers in their environment. It just gets way too much for humans to process it, right? So we have the AI ML algorithms built in there to take that toil off of you, to manage that, to be able to scale up and scale down efficiently at the most cost-effective measures. We have a great case study on our website about this from Branch. Branch is a mobile linking and measurement platform. And Mark Weiler from Branch had actually put a quote on our website about this, saying they gained full visibility by using Cast AI, Prometheus, and Grafana together. They could scrape all of our metrics, combine that with all the other metrics and all the other telemetry data that they were bringing in, and then having that full visibility into their entire environment. And that allows them to roll things out much more quickly and actually be able to quickly act on any anomaly. So from my years in observability, just some best practices and implementation tips. I see a lot of companies and a lot of organizations out there when I've been working with them that they think that they need to scrape at the sub-millisecond level to be able to see all the metrics and the data that they need. And what happens is that leads to an explosion in cardinality, an explosion into the amount of logs that you have to store. And your entire observability system almost becomes more expensive than the systems that you're actually observing. So my guidance to you is watch your scrape intervals. Keep those sub-second or 1 second intervals for those that are critical systems and environments that you really need that for. Otherwise, 30, 60 seconds is fine. You can still use those other higher levels to be able to see into your environment, but leave that smaller for your critical workloads. For production environments, make sure that you are considering how Prometheus works. Prometheus is fantastic, right? But it doesn't scale easily, and it's not exactly federated, right? So if you are using Grafana, I recommend using Grafana Alloy as the ability to be able to scrape all of that because you can cluster Grafana Alloy agents together. Add labels. So you can enrich your metadata and your data around that by supporting your metrics, logs, and traces, and being able to also have that ability to filter down. There's a lot of chargeback and showback models that a lot of companies want to be able to say, all right, for this cluster, we've got these applications running on there. One of it goes to this department, another one goes to this other team. I want to be able to do that. In Cast AI, we have something called allocation groups that allow you to be able to measure that and be able to see the cost per team. Define your SLO thresholds. It's very important to have SLOs. I've seen some companies have thousands of them. I think that's just way too many. You want to look and target your SLOs at your most critical areas. And then finally, integrating something like a Grafana on-call or an incident for your incident response system. If you want to get from MTTI to MTTR much more quickly, and especially when you're down and you're losing $80,000 a second, that's a horrible situation to be in. There's a huge amount of pressure, right? So make sure that you're integrating all that really well in your whole observability system so you can get to that MTTR much more quickly. So I left 3 minutes for questions. What can I answer for you?
When you're doing auto scaling, how do you tell the difference between something like a DDoS attack and something that's actually organic and not throw good money after bad at a DDoS attack?
Yeah, no, that's fantastic. What I would advocate as a good kind of technical architect person is you want to make sure you've got a good security system around everything as well, right? So if you have that holistic view of what's going on, your DDoS will be much more identifiable than if you don't have those systems based around your architecture. But we will try to scale as appropriate to meet the work demand that does come into those requests. Now, you can specify in our Cast AI agent specifics around how much will we actually go and how much are we going to start to hit. So you can set thresholds and other measures to put guardrails around all of those things to make sure that you're not all of a sudden just like exploding out and provisioning a million nodes kind of thing.